Hello, everyone. I don't have too much of an update today. The only update I have to give is really that. The tune you just heard on the banjo, I recently made. Well, actually, today I made a acapella video of that. Specifically, it's "Afterlife" by Avenged Sevenfold. So that is up on my Facebook page if you want to go check that out. And also, I would like to just mention that tomorrow I have scheduled another acapella video that's going up in the morning. It's a little something just to say happy birthday to my mom, but at the same time, it's cool. The acapella app has a way that you can collaborate with other people who have the app, and so my sister, who is up in Gainesville, was able to add something onto a song I was working on. So that was cool. So expect that tomorrow morning. But other than that, I don't have too much other updates I want to talk about. So I'm just going to get right into it today. I'll skip over the ad. I didn't really talk too much right now. But I have two topics to talk about today. So the first topic I'm going to talk about is just a little math topic that I've been tossing around in my head, and it's nothing new, but it's something that I feel is cool, and I kind of figured out on my own. So I thought I'd share that with you guys, and then also I have a historical engineering topic, and so that topic is the printing press. This was a device that was brought into existence in sort of towards the end of the Middle Ages, start of the Renaissance, and so I'm just gonna go over what that is and talk about its significance in history. So that's the game plan for today. But like I said, I'm just gonna get right into it. So let's talk about this math topic. And this math topic is something a little interesting. So it deals with perfect squares. So that would be your square numbers. That's 1, 4, 9, 16, 25, 36, so on. And so there's some interesting patterns that go along with these. And there's actually some patterns I could probably point out. I point in the Dosnell episode, I'll link that up in the corner there. I mentioned that square numbers actually follow a pattern, so there's only so many last digits that the square numbers can have. And for base 10, those numbers are obviously 1, 5, 1, 4, 9, 5, 6, and then it goes back to, so it's 36, and then it goes back to 4. Oh, no, I'm all messed up now. 36, 49. So it goes, yeah. So there's a certain pattern. It bounces around a little bit in base 10, but when you get back to 100, you're back to 0, which technically is 0 times 0. So 0 times 0 is 0, so that's a square number. But then 10 times 10 is 100, so that's also a square number. But I give a better explanation of this in the Dosnell video, so if you're interested in that, go check it out. But what I want to talk about today is an interesting way of calculating square numbers. And so this is something that shows up when you deal with graphing parabolics and different things. But it's a cool topic to think about. So I'm just gonna get right out and say the formula. So a number squared. And I got to make sure I write this correctly. So n is the number we're thinking about. N squared is equal to. I'll explain this in words first, and then we'll try and derive an actual mathematical a mathematic format for writing it out. So in words, what this is if you take n and you double that number. So let's take an example of 7. So we want to square 7. And in order to do it the method that I'm proposing, and I'm sure has been proposed before, what you do is you double that number. So 7 times 2 is 14. Then you take the series of it's the you take the group of all of the odd numbers between 0 and 7 times 2, which is 14. So you take 1, 3, 5, 7, 9, 11, 13. You add all of those up, and that gives you the answer for it gives you what 7 squared is. So if we're writing this out in a mathematical format, then this is going to be up until n. So we're going n times, and then we have I equals to 0, and then so this is going to be actually what we usually do is we just have I already have this how it was written. So we have n squared is equal to the summation, which is what this sigma is for. That's capital sigma. It's a Greek letter, but it's in math terms it's the sum. So that means you're adding everything up. So the sum of all right. So we need to figure out what the odd numbers are. So if I is starting at 0, how do we make the number 1 out of 0? Okay, so we need to have, we're going to have our number plus 1. But let's see if this works. If we have 0, it's 1. If we have 1, then it's 2. So this isn't what we need. We need the next number to be 3. So what we do is we say, not n. This is why I was saying it gets confusing. When you do series, you usually use n for it. So this is going to be I. All right, so it's 2i plus 1 gives you all of the odd numbers. Because if you think about it, if you multiply something by 2, you always get an even number. So if you add 1 to that, you get an odd number. So this works if you start at 0, because then you have 2 times 0 plus 1 is 1. 2 times 1 is 2 plus 1 is 3. 2 times 2 is 4 plus 1 is 5, and so on. And what happens is if you have the first n number of terms, then that gives you the digits up to, that gives you the odd numbers up to 2n. So what's going to happen is we're going to have 1, and then we're going to have it's not a semicolon, it's just a comma. We're going to have 1, we're going to have 3, we're going to have 5 ... and then we're going to have some 2 times n minus 1 plus 1 and 2 times n plus 1, and this will be our entire list of numbers, and we're just going to sum that up, and that's going to be our answer, which equals n squared. And so let's see if this works. So I don't know if anyone watching wants to give a suggested number. I'll start off here, and if you have another number, we'll get a second example just for sanity's sake. But let's pick, I don't know, let's go rough right off the start. Someone in the comments says Jaja no te ven jajaja, which is Spanish for oh, all right. Thank you for saying that. Actually, he is telling us we can't see the other section. So this is what I was writing out. Thank you for pointing that out. I'm glad that I know enough Spanish to understand that. So the this is the list that we're working with, and so we're gonna add this up. But let's start out tough for the first one. Let's pick a double-digit number just to square it. So I don't know what 13. 13. Okay, so we want to find out what 13 squared is. Now it's pretty easy nowadays to put that in a calculator, and it's pretty easy just to do that in your head. You can split up the digits and whatnot. It's not a difficult number to square, but we're gonna do this with the method that I've proposed. So the way that this works out is we need to write out a list of all of the odd numbers between 1 and 26, because 13 times 2 is 26. So we'll say 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus 15 plus 17 plus 19 plus 21 plus 23 plus 25 plus 27 plus 29 plus, oh, I have gone way too far. Okay, so this is the list we are working with, and we can start adding this up. So 1 plus 3 is 4, 4 plus 5 is 9, 9 plus 7 is 16, 7, and you'll see that all of these numbers that I'm saying are perfect squares. So 16 plus 9 is 25, 25 plus 11 is 36, 11 plus 13 is 49, or 36 plus 13 is 49, 49 plus 15 is 64, 64 plus 17 is 81, 81 plus 19 is 100, 100 plus 21 is 121, 121 plus 23 is 144, and 144 plus 25 is 169, which is 13 squared. So this is equal to 169. And so this always works. And the reason that it works, and I can give a tentative proof, it's not going to be rigorous. One thing I would like to mention is if any of you watching this know of a rigorous proof that is mathematically sound out there on the internet, please link that to me in the comments or something, or send it to me. I will put the link for that in the description so that other people can go view that for their own checking of whether this works. But so we the way that this works is obviously, so what we're doing is we're saying, let's say, I don't know, so n squared. If we have n squared, that's equal to n times n, right? So if we have n times n, that is essentially n n's. So let's say we were doing 6 squared. Okay, so that is 6 plus 6 plus 6 plus 6 plus 6 plus 6. That is, I put a parentheses and a bracket that will surely piss some people off. So this is 6 sixes added together. What are we doing when we do this the other way? We are taking 6 odd numbers and adding them together. But what are those odd numbers? Those are 1, 3, 5, 7, 9, and 11, because 6 times 2 is 12. The next number here would be 13, and that doesn't work because that's more than 12. So this is 6 odd numbers. Now, what happens with these odd numbers is if you pair them off, so you say 1 and 11, well, that's 12. 3 and 9, well, that's also 12. 5 and 7, that's also 12. So what's happening here is if you add these numbers up and take the average of them, it's 6. So it's almost it's the same as adding 6 times. It's just that you're taking 5 off of this 6 and putting it over here, and you're taking 3 off of this 6 and putting it over here, and you're taking 1 off of this 6 and putting it over here. It's just spreading out where the numbers are, but it all adds up. So this is my tentative proof. It's not formal at all, but like I said, if you have a formal proof somewhere on the internet of this, or if you know someone that might know that, I would like to put a link to that in the comments. So please comment that if you have it. But that's the general idea that I wanted to convey, and I want to thank the viewer who notified me I didn't have the paint window up on the screen. I actually did that in the last stream with my comic drawing, so nobody actually saw the comic. I felt bad about that. The picture of that is actually up on Facebook if you want to go look at that that picture. But I will be moving into my next topic, which, like I said, is the printing press made by Johannes Gutenberg. So I will play a quick ad, and then we'll move right into that. So thank you if you've been watching this long, and I hope you continue watching.